I'm going to try and shoot a video of me modifying some loom beams. Comes from the company at which I've been employed 24 years. It's a textile weaving plant, and we make textiles of whoever's and whatever's, anything they can sell. But these loom beams have, these are the old ones from the old machines, and we have gotten new machines in. These are a little narrow than what we've been using, about 180 to 190 centimeters. The newer ones are 220 to 230 centimeters wider. So this square hole right here is about 45 millimeters square. It's got 4 tack welds that holds it into this barrel or this piece of tubing. I'm going to cut it loose, and I want to keep this, and then I'll discard the beam. I'll bring another beam in, which has a male end on it, and the male end looks sort of like this, which is, we don't use this type anymore. This is off another old machine. So I'm going to cut it off to the proper width that we want it now, and I will machine this down and install it onto the longer beam that we'll be able to use. I'll re-weld it and take it to the plant where I work and hopefully show us putting some yarn on it and sticking it into the weaving machine, tying it and making fabric out of it. Textiles used to be real strong in the USA, but not anymore. But the company I work still holding on. But I'm going to do some time-lapse, and probably when I do some of the machining on it, it'll all be in the forge jaw, because these squares were made by another machine shop, and this center of this square is not really true to the bore or the diameter of the pipe. So when we stick it in the machine, we'll get a little run out in it, which doesn't really hurt anything, but I'm going to true it up in the forge jaw when I machine it down. I got to take roughly about 300 thousandths off the diameter to go into the new beam that I'm putting it in. So I'm going to do some time lapse of me removing these heads. They just unscrew. It's got like a Whitworth thread on it. Some of them has Acme, but they'll have a thread, unscrew the heads, sacrifice them, throw them away, or recycle them. Okay, we got our loom beam cut down to the right width, and those inserts here, they are. They're kind of cut out. They're pretty rough looking, crusty, been beat on. As you see these welds, this is actually made out of 4 individual pieces of metal like that was probably welded around a mandrel, and they machined it back around again. But you can see the little dividing lines right there are not welded. which is not a big deal once you get it in here and weld it around the circumference right here. It ain't gonna hurt nothing there. But the nose of it, after I machine it, these lines will show up. And I go in with a 1/2 inch end mill and I'll put me a radius in it. And I'll come back and TIG weld it all up and remachine it again. But that's what it looks like as soon as I get it knocked out of the bore. Well, it looks like a lot of work, but it also saves a lot of work. So that's why I determined it to be worth scavenging these out of it. And I've already got two ready to go. Here's what they look like after they're machined. You can see a few holidays and spots where I TIG welded across that face. It's not going to hurt anything. But retap the holes, chase them, put new bolts in it. The diameter's cut to the proper size. But I've got one of them in the lathe already indicated, and it's kind of hard to get this thing running dead true anyway because of how bad they're beat up and stuff. It makes it kind of hard. But okay, here it is indicated in there. But you can see it's had a BFH a hold of that. Now, that's what makes it so hard to indicate, plus the bolt holes in it. This is running out within 5/1000ths, you know, just with the stuff here on it. And normally how I'll determine whether this is true to this is I'll mark this thickness. And it was all within like 3/1000ths of an inch, which is fine for me. So I can indicate off of this. And if we've got one, they'll all be slightly different. But if we got one of them that this is running way off, then I'll indicate it off of the center bore here. I've got a mandrel that I'll push up in here that's round with a spot drill on it, and I'll indicate it off of the spot drill with a coaxis indicator, and I'll get it true. But this in here is, this one's okay. So we'll fire the lathe up and get to machining. Okay, we got a little bit of machining in there of the insert. Got it done. And I'm going to take this beam here, I'm going to set it outside and take a, it's like a grass burner, a huge propane fired rosebud. And I'm going to heat the inside of that up, stick it in there and heat it. And all this tape that's on this beam, I'm going to remove it, get all the tape off of it, and that'll put a little preheat in it. Then I'm going to take the very ends of them and I'm going to heat it up and check it with a telescopic bore gauge. I'll check it till it swells it up, the heat, enough that we can get the insert in it without any pressing or anything. I'll slide it up there and let it cool down. It'll clamp onto it. Then I'll take and MIG weld it and paint the ends of it, and the beam should be done. And then we'll take it to the plant and do some more filming of that. All right, we got all the inserts in. It's done. When I take it back to work, I'll install some new boats there. So I'm gonna load it on the truck and I'm gonna take it to work. And this will be called done. Okay, I'm inside the plant right now. Hopefully you can hear me. So I'm gonna go out and show the warper putting the yarn on the beam, and then I'll show it tying in the loom. I'll do this at a time lapse, but most of the time you can't even hear what's going on in here. It's rather loud, but here we go. Okay, here's the weaving loom making fabric. There's the warp and the beam in the machine. Here's the end. One at a time, go through what's called a drop wire. If it's strain breaks, that'll drop down, ground it, and stop the machine. Well, it runs up, runs through a harness. Each one of those little harnesses have an eye on it that holds that end or that strain, and it takes it up and down in a particular motion. This weave's called plane weave. The same amount of ends up as you do down. The machine rolls over one time, and what was down becomes up. What was up becomes down. And it inserts a piece of string called a weft. It inserts it through that package onto the winder and through the machine. This detects when that end breaks, it stops the machine off. We'll go around to the front. This machine just broke one of the warp strings in it. The weaver goes in, finds out which one is broke, ties a knot back on it, draws it back in the machine, starts the machine back up. Stop the machine and kind of show you the action of them needles bringing down them strings that are in it, the filling or the weft. And that rapier head grabs it, opens it, grabs it, a little scissors right there, cuts it, takes it out through center transfer. It hands it to the other one. Carries it to the other side, harness is switch, reed comes forward. This right here is called a reed. Then it does the motion all over again. That's how many RPM that it's turning. And that's how you produce fabric. Okay, that's kind of how you make fabric in a nutshell. It was not very that thorough. but kind of give a general idea of how it's done. So making the loom beam, then putting yarn on it, tying it in, making fabric. The process is pretty much the same no matter what style of fabric we're making. But hopefully you enjoyed the video, and thanks for watching.